Today's wind farms rely on fiber optic cables for much of the data transmission. Information generated by the various sensors in the turbine is transmitted digitally using pulses of light via fiber optics cable, eventually collecting on a server. A technician miles away from the site can determine the status of an individual turbine or the entire farm. Fiber optic lines are thin, flexible, transparent strands of optically pure silica glass or plastic used to transport digital data via a light source. These strands are typically smaller in diameter than a human hair. A fiber optic strand consists of multiple layers. The actual conductor is a silica glass or plastic core. This core is surrounded by a refractive coating called cladding, which provides a reflective surface and causes the light to travel along the entire length of the core. The third layer is a buffer coating to protect against moisture and other damage. It also prevents light from escaping the strand and may have a color coating for identification purposes. Fiber optic strands are typically bundled into a cable. These strands can be grouped as either tight or loose buffered cables. Both types of cables contain some type of strengthening member, such as aramid yarn, stainless steel wire strands, or gel-filled sleeves. They are, however, designed for different environments. A tight buffered cable consists of one or more bundled fiber strands covered by an outer jacket. Often the outer jacket contains multiple layers to add structure to the cable and provide water resistance. In loose buffer cables, the fiber strands are contained within buffer tubes, allowing the strands to move freely while also providing additional protection for the strands. The addition of buffer tubes and other protective layers causes the cable diameter to be larger and the cables to be less flexible. It also means that tight buffer cables are more easily damaged than loose buffer cables. These factors make tight buffer cables more appropriate for indoor use and loose buffer cables primarily for outdoor use. Fiber cable that is used outdoors is normally filled with a waterproof gel. The buffer tubes may also contain this gel, as well as a water-blocking coating between the inner and outer jackets. Both inner and outer jackets are made of materials designed to resist corrosion and add greater protection to the cable. Some cables also have a metallic armored coating for strength and to protect against rodents. Fiber specifications list the core and cladding diameters as a ratio. Multi-mode fiber is usually either 62.5 by 125 microns or 50 by 125 microns. Single-mode fiber is commonly 9 by 125 microns. Fiber optic cables have many advantages over copper cable, including immunity to electromagnetic interference and radio wave interference. They are smaller and lighter than copper. They are capable of greater transmission distance and higher bandwidth and have less signal degradation. The greatest advantage is their ability to carry digital information over long distances at significantly higher rates than copper. For example, fiber optic cable may reliably transmit data up to 10,000 meters compared to a few hundred meters for copper. This means that fewer cables are needed, fewer signal repeaters are required, less power is used, and there is less maintenance. Fiber optic cables also are considerably smaller in diameter than copper cable, making them lighter to work with. These attributes, combined with increased resistance to lightning strikes, make fiber optic cabling ideal for data transmission at wind power sites.